Hey guys, this is Tolly and welcome to Let's Build a JRPG part 27 technically. We're going to be working on some more tile map stuff. So essentially we just finished streaming for 2 or 3 hours, probably 2 hours. And we just finished working on a upgrade to the console app tool that we have to be able to take a input tile, a isometric wall, and to convert that into 12 different facings for that wall. And we have from the previous part 1 tile map generation video this tool now that allows us to create tiles and a palette out of a folder of images. So we can create all of these bricks that we have. We can turn all of those into tiles and then assemble those tiles into a palette so that we can just immediately start using them to start painting in the scene. Like so. I think there's more that I want to do, maybe generate even more types of tiles potentially for some more complicated cases. But the next big thing is we have this generator that we worked on in part 1 of the tile generation video 2 streams ago. We want to advance that. That's why this one's called Tile Map Generation Part 2. We have it so that if we hit generate on this thing, it will make a map. This is a pretty boring one, but we can generate a bunch of these and we can choose whether or not we want to have double sized walls or single sized walls, but we can make a little environment out of this. And that is based off of these maps here. So this map here, I have zeros in for where all the black is, and all of the ones are floors essentially. And the generation code we have will convert that map into this. We download it as a TSV file, and then we parse it in and we generate set a bunch of tiles on our tile map based off of that TSV's information. The issue is we want to try and move towards this idea of these kind of partial tiles. So instead of having tiles that have the tops here, we want to actually try and do where's a good one? This one here. We do this here, we want to do this here, and then we want to try and change it so this one's here, and we want this to be a diagonal one right there. But this means that every wall tile that we place can no longer just be one wall type. We were doing this before and just setting all walls as 0. What we want to do now is we actually want to have this not take in one type of wall, but 12 different types of walls. And when we place a wall, we actually want to do... I'm going to get rid of this logic for now. That was something I was playing with earlier. We want to actually do some kind of math here to determine what's around this tile. So when we build this map, we should be able to say if we're here and there's a wall tile north of me and a wall tile to the west of me, then I should be and there's no walls around me anywhere else, then this should technically be a southeast tile. So if there's one up to the north and one to the west, then this should be a southeast tile. And we need to write basically some configuration logic that will look at each wall and go, there's something to either side of me and nothing above or below, then I must be a south tile. And we will have to write that logic, and then we'll check every tile as we go to place it, and then put down the correct tile is the plan. So let's start with that logic. So we know when we go to place these tiles that we say at tile position, we want to place this thing. How do we figure out this tile position? This is based off some magic, huh? Better question. What is column X? Column X is technically the value I'm looking at. We actually don't care about the tile position. What we care about is the column. The issue is our data is in two arrays, essentially. So if I want to know what's in the tile above me, I have to check in a different row potentially and a different column. It might be better if we read all of our data into a two-dimensional array. First. Okay, let's start there. This might be the wrong approach, but I'm gonna start with this idea and see where it takes me. For now, so that it stops complaining so much about everything, we're just gonna comment everything out. Cool. So we want to do a two-dimensional array of tiles. Technically, the tile map is already a two-dimensional array. What if we have to loop twice anyways? Because we'd have to loop through all the data to create a two-dimensional array. What if instead we just process it twice? That might be faster. There we go. So looping through the exact same data again with whatever flips and everything that we have done a second time. We lose column length if we don't split the rows. So we technically need to split the rows again, even though we won't use the columns. This might be the quickest and easiest way to do this, but I'll try and think of a better way after. Hey, Tempest. Not sure when you left that comment. Working on map gen stuff again? Or still? Yeah, I'm still working on map gen stuff. We're trying to make it so that we can change our walls from one tile to one of 12 tiles, depending on that wall's facing, essentially, is what we're working towards. So I hope I can get it done tonight. I probably got another 2 hours in me, maybe an hour and a half if I fade real quick. But I'm real excited because I think we're getting real close to being able to hit generate and getting something that's, you know, got a little bit of logic behind it. I want to convert this, I think, into a function. So let's right click, refactor, extract to method, and this can be, oh, it literally comes out as a tile position. Fantastic. Calculate tile position. Sweet. And now we can use that exact same thing down here. I think this should be part of that calculate. I think I just didn't select it when I was doing that initial setup. Okay, so that'll calculate a tile position. And then now we don't have to do this logic twice. We just have to call that same function. And here, what we're going to do is instead of setting the tile map, we're going to actually do a dot get tile given a position. and that's going to return a tile base. So what is a tile base, and can we tell whether it's a wall tile from that tile base? Tile. Let's just call it tile. Not a public one. Boo IOU. Not a public one. Get tile data? Get type? Refresh? What's the name? Let's try logging the name of the tile. Maybe that is something that we could possibly use to tell whether it's a wall or not? Because, like, we could build all of the walls into a two-dimensional array, but at the end of the day, technically that's what a tile map is. So why not just build all of the tile map once with all the walls being, like, base tile, and then rebuild it a second time with all of the tiles as, like, the proper one? So let's try running this, and I'm actually going to attach the debugger so we can see what data is in tile. If this doesn't work and we can't tell what an actual tile is, then we'll have other problems, but I hope we should be able to, because I have other plans to use the palette, which is a tile map as well. Yeah. Okay. Let's hit generate. Tile position, 54 apparently. Null. That's going to break then. So if tile does not equal null, because sometimes we don't have tiles in spots, and that's perfectly valid. So then we'll check only when it's not null. Run it back. Okay, tile is simple wall export. Okay. Sprite. Its sprite is simple wall export as well, so we can tell what its sprite value is. Its game object is null. Interesting. Has locked color. Has a collider type of sprite. Has a name. Okay. That name might be all we need then. Oh, null reference. Oh, was that from before? Oh, wrong button. Generate. What is happening? Oh, there we go. Okay, yeah, so it is printing the name of the tile. So as long as the base name is wall, we know whether or not it's a wall tile. Tile.name contains wall. Okay. We're going to need the exact same enum we built in our system over here. For now, we'll stick it at the top of the file, but we should put it in its own folder because it might be useful for other things later. But we're working quick. If the tile is not null and the tile's name contains wall, then we want to check if, given that tile's position, we're going to want to check every tile around it. This is not great game code. I wouldn't write this for game code because this is going to be super clunky, but we're going to hit generate one time and we're going to be done. And like if it takes 5 minutes to generate, I'm kind of okay with that because it's going to save me hours of work of like having to place every tile by hand. So this is going to be kind of garbage, but that's fine. So we need to do some sort of function essentially that is going to be a private function called get wall type, which should return a wall type. And it's going to need to take in a tile map. And it's going to need to take in a tile position, which is a vector3 int. Vector3 int. And that's my tile position. Okay. What are you complaining about? Oh, it doesn't return anything yet. So for now, so it stops yelling, it'll return north. Okay. And then we will get wall type given our tile map and the tile's position. And then with that wall type, we will do some magic, essentially. Tile map, set tile for the original position, and this will need to be a magic function as well. So this is going to be get wall tile from wall type, and this is going to take in a wall type. For now, this will return wall, but we're going to do something in a bit to make that actually work correctly. Okay, but that's basically the functions. This needs to return a tile. So we have to do two things. We need to set up this function to calculate a wall type for a given tile in the tile map, and we need to set up this thing to return a tile based on wall type. And that should be it. It's going to be a two-step process, but that should do it. Let's start. Let's start by setting the palette. This is something I've been wanting to do since yesterday when we first built this thing, but instead we just hard-coded the tiles. But I don't want to set tiles. I want to give it a palette, and then I want it to generate everything based off that palette. So, and we can do this by replacing, we can test this part by replacing this. So we're going to get a palette, and we're going to set that. And instead of floor, wall, and sewer, what we're going to do is we're going to from the palette, we are going to get palette.getComponent in children tilemap. All a palette is a tilemap. So we can get a private tilemap palette. Be explicit with our names so that they're very clear. Okay, palette tilemap is whatever is off of this. If that equals null, we're just gonna leave. We should also probably debug log error invalid palette set in generate tile map from TSV. Cool. Just going to add a bit of error logging. So now we have this tile map. Instead of setting a tile, I think what we can do is floor name. Default wall name. Water name. I'm not sold on this for the final way of doing it, but this should work for now. And then we want to do a get tile by name, floor name. Actually, you know what? Let's rename this to floor tile name. It's even more clear. All the clearness. Okay. So then we need to make a new function. Bloop. Get. Oh, this is supposed to be tile. Get tile from name, string, tile name, palette, tile map. You can get tiles this way. Is there a way to get all tiles? Or a way to get tile by name? This is to get tile by position. Let's see. I'm pretty sure I saw a link. Found it. Oh, this is awful. Oh, this is truly awful. I'll show you. Don't worry, it's coming. We want to grab this function. So This is going to loop through the entire tile map of its entire size, and if a tile is not null, we will add it to the tiles. And this returns a list of templated type, where it's a type of tile. That's not what we want. What we want is, we don't want to get all tiles. We want to get tile names. And we want to pass in the tile map. Honestly, we don't even want to pass that in. We would just want to use tile map. Sorry, palette, tile map. No, that's not it. This is a static function. That's why it's not showing it to me. Tile. There. Doop, 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 doop. Okay. This is now going to return a, let's make it a list of strings. Names. Oh, technically we still can't get a tile by name, can we? So getting the name doesn't help. We need to store this somewhere. Populate tile names. And instead, we're going to make a dictionary. Private dictionary of strings to tile map. No, to tiles. And that will be called tile lookup. That's equal to a new dictionary. Okay. So we're going to make a thing that is a list of strings that map to tiles. And this won't even return anything now. This is just going to be a populate function that we call that's going to do this logic. And it's going to run through. It's going to get every single tile. If that tile is not null, and that tile, and if tile lookup does not already contain that tile dot name, then we will do tile lookup dot add tile name tile. What are you upset about? Get tile. Oh, it's getting specifically a tile base. Sure. Does that mean this needs to be a list of tile bases then? What's the difference between tile base and tile? Tile specifically inherits from tile base. Okay, so yeah, we definitely want tile base, because otherwise, if we make special types of tiles, we want to all inherit off of the same one. Okay. Oh, I didn't see that that was a question, Tempest, that this awful or just awful? This is pretty bad. I'm pretty not super stoked about looping through the entire palette from its origin Y all the way up to its size. It's not great. But it looks like this code should work to get all tiles in a palette. So then we're gonna get the tile map. As long as it's not equal to null, we're gonna populate immediately after it, which will populate our dictionary, and then from there we can then use this to return a tile by name, which should return a tile base, which this now has to return a tile base as well, I would guess. tile by name. This should get sewer. Or no, I called it water. Water tile name. This now needs to be a tile base. Get tile from name, by name. I like by name more. That was the one I did first. I did it wrong the second time. Okay, and then we do the same thing here. This will be default wall tile name. Yada yada. Default wall and floor. Technically better if we do it this way. Right now we're setting it to a variable every time, but we could just use the names to set them immediately, which is technically a little bit better. And then we don't need this current selected. Simplifies things a little bit. I think current selected was when I was thinking that I would do the logic outside of the switch statement, but it's just now the switch statement does all the logic. Okay, so that should be working. And this should work too now, technically. So what we need to do here is we need to... we need to do a partial search on our lookup. Okay, another bad thing. So you shouldn't do this. Don't do this. This is bad. This is super bad. But, you know. You shouldn't ever for loop over a dictionary. If you're doing it means you've done something wrong, is generally what I've heard people say. So I acknowledge that I've done something wrong. But I also acknowledge that I'm not sure how to better do this. So we'll get it working, and then I'll stare at it after stream for a while to see if I can figure out a better way to do this. So .key contains wall type .toString. So what this is going to do is if the name of the tile contains N or S or W, then that's a valid pick. But it shouldn't be valid if it contains multiples. So how do we check versus that? Do we have to like... because technically they have overlapping names. And we don't, the name won't just be north, south, east, west. We could do that, which would make this easier because then we wouldn't need to do the for loop. But I think that's an unrealistic expectation to like be like, these names have to be just N. But if this is E and this is NE, and this is SE, there's no way to tell whether or not it's an east brick, a northeast brick, or a southeast brick, unless we're specifically looking for a southeast brick. But even then, it could be a southeast inversed, or a southeast corner. how do we tell these file names apart? How do we tell these apart? But we basically want to say, hey, based off this wall, I'm expecting to find a tile that has its name. Let the badness continue. If we're already down the road, let's continue going down the road. Where's that switch statement I already have in that other code? Should be able to just grab it and use it again. Let's just copy and paste if switch statements. For me, it's 9:40. We're now at the stage where we're going to double down on our bad code. It's just what's going to happen. All right, so we've got a series of switch statements. And we're going to loop through this switch statement. Oh, God. All right. So if our wall type is east, and if the key value key contains wall type east, and doesn't contain the word corner, then we can return key value pair value. Valid string invalid string. I just don't want to loop through the switch statement that many times. Instead, what we can do is we can say valid string if it contains valid string and does not contain the invalid string. Okay. Now in here, we just need to set what the valid string and the invalid string is. But we're doing this in one switch statement at the top instead of doing this switch statement every single time we loop through. So if it has east in it, it's valid. I mean, still technically easier for me just to do toString on the enum. And then I only have to do this at the top. Then we just need to figure out what the invalid string is for each of these. The invalid string for this one is corner. And we can do that for all of the base versions. If it has the word corner in it, it's wrong. And then for this one, if it has the word inverse in it, then it's wrong. And then these ones don't have invalid strings. If it's exactly inverse southwest corner, then that's the right word. You are correct, BooIOU, that I could use regex. I know what regex is. I have heard of it. I know it's for string parsing. I haven't dove deep into it. So I do believe you that regex is 100% the right way to handle this. I don't actually know how to use it though, and I don't feel like figuring it out on stream. So we're gonna go with this, and I think this will work okay. But regex, I could just do dot select. No, dot compare. I think I could write a comparer with regex, right? Is that? I think that's how that works. And then we wouldn't have to loop through. Well, technically it would still be looping, and it would still be doing all of this, but it wouldn't be 20 lines of code. It'd be like 1 line of code. Okay, so this should work though, as gross as it is. Given a wall type, we should be able to find it from our table as long as it's in the palette that we have set. We should be able to grab the correct wall. We're writing a lot of code without testing anything here though. Let's now do, oh, is it match? No, I think it's compare. Again, I'll look it up later, and if I figure it out, I'll mention it in the next video. Next up is we now can get wall tiles from a type. We can also get tiles by name. We can set those tiles in the first pass. We shouldn't be needing the original things. Okay, and the reason we do this and why this is better is now we can just swap pallets, but as long as the names remain the same, it'll all still function. So we can have the exact same TSV being used for, say, where is it? We can have this TSV for, like, this is labeled Ice Cave. We could load it up with Ice Cave, or for, like, you know what, this layout isn't really feeling it for Ice Cave. Let's try it as like a Desert Ruins. We could just swap the palette, hit generate, and it'll make a different version. Because the palette should have everything with the same naming scheme. That'll be like the one requirement, but that's not too bad. We can have something that's a reasonable naming scheme. Okay, so the last piece is figuring out the walls, calculating the wall type. Okay, so this is where we get kind of gross again. I don't know how to do this better, but we can do get tile. And given the position, we'll want to do this for a myriad of directions. Specifically, we're going to want to get vector 3 north position, which is going to be equal to this plus vector 3 dot up. We're going to want to get the northeast position, which is going to be a new vector of 0, 1, oh, I don't know the coordinate scheme. I don't know which way is east in our tile map. So we're going to guess. I'm going to assume north is up, but for east and west, oh, this might be based off orientation too, because we have this stuff that lets us flip around which way we want to draw the map. And it does some calculations based off of that to get like new positions. We're probably going to need to take that into account as we set the positions here as well. For now, let's just put in something random. Let's say that east is 1 and west is 0. And then let's keep moving forward. So this will be east. So that'll be 0. This will be south. east, which will be -1. This will be south, which will be 0 here. Technically, I think I can do down. I mean, slightly more efficient because we're not having to new a thing. As long as we keep things consistent, it should be fine. Southwest and west. West will be left, right? And left is negative, so this will be negative and negative. And then we need northwest. 1, 2, 3, 4, 5, 6, 7, 8 positions. That looks right. So this just needs to be +1. And then positive, 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 negative, 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 positive. Yep, that's all the configurations. Now from here, we need to check every position. So we need to get every tile. Tile base, probably. North tile. We need a function. We're going to be copying and pasting a bunch of work. So is tile wall is what we want to do. And in that, we want to pass in a position. Tile position. And we want to get a tile from that tile position. Then we want to check whether or not that tile.name contains the word wall. And return that. Then we want to do that for each of these positions that we set up. Can still instantiate them all this way. I could just put in this value directly. It's probably better. Wish I had thought about this beforehand, so I didn't have to type everything twice. I still think there's probably a way I could reduce this down even further, honestly. But for now, I'm gonna just keep chugging, wasting time by not being efficient. Okay, and then this will tell me whether or not each configuration is a wall or not. Then we will need to write some code that will need to determine how we figure out whether or not something is a specific wall type. Okay, so up, right, down, left, 1, 1, -1, -1, -1, 1. Yep, okay, that looks right. Copy and pasted that over correctly. So now from this, we need to do some sort of checking against these cases. Ooh, bit operators would be the way to do this. Bit operators would be good. Okay. Because I can either write a heck of a lot of if statements, or I could do some bit masking. It's been a while. I know that's the correct way to do this. Because we have a bunch of these. The main problem, I think, is what if multiples are? Because we're assuming right now that if a, let's go back to my copy here. If a tile north of me is east and a tile west of me, or sorry, if a tile north of me is a wall and a tile west of me is a wall, then I must be a southeast wall type. But what happens if this is also a wall? Or this is also a wall? If this is also a wall, it doesn't matter. This is still southeast. Do we only actually care about our cardinal directions? Because whether this is a wall, this is a wall, this is our wall, or this is a wall, I don't think it matters. Because even these inverse tiles... I think it's just based off cardinals. That's my guess. My guess here is that if is north wall and is west wall, return wall type southeast corner. If is north wall and is south wall, return wall type east. Ah, no. No, because this could be east or west. Both this one and this one have the same criteria. You have to check the floors. Or more accurately, you need to check for null. I think. Okay. What if... I think we need this functionality. Sorry for going quiet. If and Interesting. Undo, 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 undo. Redo, 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 redo. We do want the positions because we're going to use them multiple times. I think statements are true. Based off of whether or not the piece above or below has a tile. So something is a southeast corner, specifically when there's something on either side of it. Something is specifically a east or west or north or south, like just without the word corner, is if it has its things on either side of it is a wall, and the one to its opposite direction is null. So if its east position is null, then it's west. And if its west position is null, then it's east. Okay. And then it's the same thing, but with the opposite logic. So this is now is east a wall and is west a wall and is south position null, then I'm north. And then this exact same logic, but with north position, should make me south. And those are the cardinals. Then we have the diagonals. I'm going to simplify this down by getting rid of the brackets. Okay, and then if it is north and west, it's southeast. If it's north and east, it's southwest. If it is south and east, so I'm still missing something. Shoot, this logic doesn't work. There's a way to make this okay, but let's keep working through it. So let's finish this. So, and then we'll tackle one problem at a time. So south wall and east. So if it's south and east, this one's south and east. So this is south. This is a east facing wall. This is a north facing wall. This is a northeast facing wall. So if it's south is a wall and it's east is a wall, then it's going to be a northwest corner, I think. If it is north and west, then it's the inverse. Oh, did I think I copy and pasted over the wrong one for a second. If it's south and east, it's northwest. If it's south and west, it's northeast. God, what a mind bender. The problem is this one, because technically this is south and east as well. Okay. Corners. If I have wall, 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 this one should be a this is a southeast corner. What is this one, this one, this one, and this one? This would be a north facing. This would be a west facing. So this would be a northwest facing. And in this situation, the way you tell is by this square not being null. That's how you tell whether or not it's a northwest or a southeast inverted. Or the opposite logic. So northwest is south is a wall and east is a wall. And then there's sub-logic or extra logic, which is and is tile null in the southeast position. That means it's this. Otherwise, this exact same configuration is a southeast inverted. Holy smokes. Okay. That means every single one of these have a opposite conversion. So this one here could also be an inverted. So southeast here needs to check whether or not it's northwest position is null. And if it is, it's southeast. Otherwise, if it's not, it is a reverse. So probably northwest inverted corner. That's my guess. If we have north and east for a southwest corner, north and east, then we need to check again the same thing, northwest or northeast. God. These should all be lowercase. Bear with me for a second while I fix my naming scheme. Local variables should in fact be lowercase. Okay. Where was I? Here. Northeast position. If it's not null, then this is actually a northeast corner. Then finally down here, if the logic stands, then this should just be southwest. And then this should be southwest inverted. Okay. Now this function should get wall type. There is a possibility of getting to the bottom without hitting something, in which case we should just send back north. And then we'll want to look for north when it's a problem. Or we add an invalid to the bottom. That might be better, so that we can catch invalid problems. Okay. We never used any of the diagonals on the walls because we're checking actually versus null, not wall. Okay. But that seems to work fine. That looks okay. As long as the default name for the floor, wall, and water are good and the wall is there, it should work. Okay, that was probably what, like an hour of writing code nonstop without testing anything? Let's see how long this takes to actually get working. Okay, first off, we're gonna need to make sure that that these guys have a default wall. For now, let's make that, actually, to do this correctly, let's copy over some images so that everything is in the palette and it's generated properly. This guy. This guy. This is who I want. I want this one in test tile. And his name needs to be wall. It has to have wall in the name. Hard rule. Then we need water tile, which I think this has been the one that we like. What was that? Floor, wall, water? Okay, we want this in here. And then we need a floor, which we've been using the latest one, gray stone. And this... I'm going to also just call... We need to come up with a naming scheme. I'm going to have to put that on the agenda for me and Drixie to go over with some of her art stuff. It's going to be necessary. All right, create tiles and pallets. Okay, now this thing has the water tile as well as the default. So I think I need the exact names. Or did I do... Oh, wrong application. That's the art we worked on in the last stream. Did I make this exact with the get tile by name? I did. I did make it exact. Tile name. Just making this more robust. Okay. it still requires an exact name. I think I want to make it null by default. Okay. So that means that I need the exact name of these guys. So this tile is floor gray stone. That's its name. This is floor tile water. That goes there. And then wall. Sweet. Now, this is going to break in one of several ways, I imagine. Let's see which one it is. Generate. Ah, the way in that nothing happens. Good. Good. That's a good break. No errors? Oh, we're showing these things. Warnings? Don't care about warnings. There were no errors. Great. Nothing happened. Nothing happened and there was no issues. But it also didn't render anything. Fantastic. Let's try commenting out the second pass at first. This should do exactly what it's always done. But now with our new palette system. So one thing at a time. That doesn't work. Okay, okay. I'm going to guess then that we're not finding tiles by name. We're probably not populating is one option. The other option is that the lookup is failing. Let's see which one it is. Populate names. Do we ever get in here? No. No, we don't. Does not contain. That was a pretty silly one. All right, that's not the worst. Generate. Populate. Okay, now we're populating names. Cool. Now it generates. All right, that's not the worst. That's not the worst bug that we could have ran into. And I found it pretty quickly. Now let's try step 2, which is replacing all the walls. Let's see how this goes. Generate. Populating. One corner. All right. Errors? None. Okay. Our logic worked. 1 of 8. Fantastic. All right. Where do we go from here? Likely our names are not getting found because all the other stuff loaded. We're not plussing on the y-axis, so all of these floor tiles on the lower level should technically be getting hit as well. Oh, except I don't think we check on 2 different levels. Tile position is always Z valued. That's why none of the ones below got modified. Okay, so we're only checking on the base layer with this pass. All right, so let's see. Assuming a wall is a tile, let's take a look at what's happening. Let's start there. Okay, so we hit a wall tile in our debugger. Oh no, we hit populate names. Okay, so we hit a tile. That wall tile type came out as inverted southeast. Well, that's not this one. Well, at least I don't think it should be. So we should see this coming out as we're looking for something that has a valid string of inverse southeast corner. And in our tile lookup, we have 15 things. And inverse southeast corner is a valid brick. It should be number 5. So let's add to watch this. Nope, not that one. It's not going to be stone floor gray. It's not going to be floor water. This is northeast. Not going to be that one. Northwest. Nope. Southeast corner inversed. That should be this one. Did not work. It contains spaces. Is that what it is? No. This isn't a space. That's a... This should have been a valid key. Okay. Is valid? And is invalid. Let's get some bools in here so we can see what's happening. Okay. Try that again. Wall type, southeast inverted. We skipped over it. That's fine. Wall type, invalid. Ooh, we got an invalid. Okay. Invalid. Invalid. Getting lots of invalids. Interesting. So I must have clearly misunderstood something. Let's hit generate again. Let's at least check that southeast one. So southeast corner inverted. It's not this one. It's not this one. I think it was like number 5 or something. Not this one. Not this one. This one. Okay, so is valid. Is true. Is invalid. Is false. This string is nothing. Does it not contain nothing? Is that statement incorrect? Is the statement that I shouldn't be checking against it? If invalid string is not set to anything, or is probably the correct way to get this logic to work. Okay. Generate. All right, we got some corners. One by one. Next step. Let's see why we're getting so many invalid results. Generate. Debugger. This one is inverse corner, which is fine. This one, we get all these positions, we get all this info. Okay. Is it a... Let's just check this. Is north wall false? Is northeast false? It is an east wall. It has a wall to the east. And a southwest. Interesting. So the position on the map is a position where it has a... Let's delete all these other watches. see them all at once so that we can get a better idea. Okay. So it has an east wall. And a southwest wall. A position where it has an east and a southwest. And that's it, huh? Do we know what the tile was? Like, what was the tile? The tile was a wall at tile position 652. Interesting. Let's write some code to help us understand. If wall type is invalid equals, man, it's getting late, invalid, then instead we want to set this to, let's get a sewer, because technically this map doesn't have any of the water tiles. So set it to a water tile so we can see it very easily. And then we want to break, I think. Hopefully that gets us all the way out. Generate. That's not... What? What? Oh, I default wall. I want water. I typed in the wrong thing. Although it does look like it's not breaking out. These make sense. Oh, we're modifying as we go. And these things don't contain the word wall. Okay. Let's fix that. And we're going to fix that in what I consider to be the easiest way. We're going to change this to wall sewer brick. We're going to run the application to make all the different parses of it. We're going to run it twice because I forgot to delete the old ones. So we're going to run it again. We're going to take all of these tiles. We're going to go into test tiles 2. We're going to delete all of these except, should be easier to do here. Should be these ones and these ones. Delete. Then we go into here and paste them. Okay. Then we create palette. Then we go here, generate. Just gonna really make sure these are all gone and recreated. Ooh, interesting. Now it's back to failing. failing to create anything. Is that because I gave everything the word wall now? Okay. Generates. Cool. Save. Generate. Generate. Interesting. This one breaks, but that makes sense. This is an invalid piece because it technically doesn't have anything to the side of it. So it only has one friend, and that's a problem. Okay. Let's not hit return then. So I didn't really explain it, but the actual problem we were running into was all of these other tiles weren't named wall, and we were creating everything, and then it would check next door, and it wouldn't be a wall anymore, meaning it was invalid. Okay. We have a bit of a ripple effect that comes from here, it looks like. Based off of the order. And potentially an issue over here as well. Oh, no, that's this map in specifically. Let's... this sheet 0, 1 replace with 1, replace all, undo. Oh no, undo. Yeah, it's 0, replace all. Good. I was playing with some things, making it 0-1 as like a different type of download or a different type of wall type, but let's re-download this. You know what, let's make this, yeah, no, we'll save over 1. That was very loud. Generate. Okay. This makes sense. This makes sense. Okay. So the way that we're going to handle this for now, because basically these are causing a ripple effect because we start here on the left. This is an invalid tile, so we set it to nothing. Now this one's here and it has nothing to the left of it, so it says it's an invalid tile and it sets it at nothing. Then it just chains all the way through until it finds one that has like multiples around it, and then it sets properly. So we got to fix this one. So this one here only has 1 to its east. So we just need to add a little bit of logic just for that guy. I want to find a better way to handle edge pieces, because I actually think they might want to be yet another type of wall. But for now, this is a south tile. If my... south and north is what we need. We need them to be south and north if I have a east wall. And this same logic applies, but it doesn't have to be both. If we get to the very end and there's I only have one to the east of me, then sure, whatever. And that should hopefully fix that main issue, which is coming from that guy. Then we just have to find other invalids. Interesting. This one is using the wrong corner. This one is using the wrong piece. Okay. Okay. So we have some invalid logic in a couple spots, actually, or in most spots. Oh, that's funny. Centrals are their own problem. Huh. Okay. So lots of issues, but it's getting there. It is getting there. What does this look like in game view? Interesting. Very, very interesting. Okay, so let's start tackling these one at a time. This one, what is going on with you? I would expect you to be a inverse tile, in which your neighbor to the east. Let's look at him in the map here. This guy here. So he has someone to the north and someone to the so we want this guy to be an inverse. Okay, we might be done, folks. I feel like my brain is becoming mush. We're so close, though. It's just going to be figuring out the logic. That's going to be 99% of this now, is just going to be fiddling with these if statements, trying to get all of these to put in the right walls. But we technically have it working with pallets. I don't have another pallet to try, but in theory, if I dragged in a different type of pallet object that had walls, floors, like these objects with the right names, should work. I also think these should not be exact names. I should be able to just put in like floor and it'll just pick one. Either that or like brushes might be a good idea too, which is another thing that they have. Regardless, yeah, it's just these walls, and I think it's going to be a bit finicky, but like, look, this corner works, and this corner works, and this corner works, but not this one. This logic is backwards. But I think that's because these ones are backwards because they're actually over water. So there's actually nothing on both sides. So it defaults to one of them, which is interesting. Which might mean that we have to take depth into account as well. Yeah. That would be a reason to actually go and do a 2D map instead of using the tile map twice. Because we've created depth in the system once we've calculated this. Because we manipulate the positions of objects. But technically the water doesn't have depth when we're first looping through it. We could move the water after the fact too, but then that's a third loop. It might be better just to make this into a two-dimensional array, then loop through the two-dimensional array and set all the tiles in one pass. Interesting. Then we wouldn't need to be checking against, like, wall types for the tiles. We could just, and we wouldn't need to be going get tile. We could just check versus the string value. Yeah. Yeah, we should probably turn this into a two-dimensional array of strings. Loop through and put everything in a two-dimensional array. Then do this logic. That's probably better. You, though. Where is your if statement? You're saying that you're a... Wrong one. You're saying that you're a... North... You're the same as this one. Oh, it's the same reason. There's water on the other side. So it's null on both sides here. Or we check this tile to see if it's not nothing. And here it's nothing because technically the tile is one down. Or two down in our system because each half step is half a tile. But yeah, so that's why this one's busted. It's all to do with water. Huh. So then if we bring back in the ice caves and we download this one as a TSV. Let's make this one 5 because I don't remember which one it was, so I'm just going to download it as 5. And if we generate this one, that looks correct. So it's possible it's just water that's being the problem. And that's because of the depth change. Okay, let's see how this looks. Let's use joystick because it's a little bit easier. There's a gap there. We can head down this way. This all looks right. These corners are correct. Yep. Yep. Okay, okay. Good. I'm actually pretty pleased with that. That means that we just need to do some logic to deal with depth / to put it in a two-dimensional array before manipulating the walls so that we don't have to worry about depth. But this all looks correct and to be functioning. There's still the invalid cases of the ones that are on the edge that aren't connected to two tiles. We'll have to figure out how to handle those a little bit better. But this seems to be fully functioning. Yeah, those are all corners. Those are corners. Cool. This should allow quick and rapid iteration of maps and having them be simple and easy to build. Try like Drixie can build one tile. We can run it through the processor, make a pallet out of it, assign that pallet to the generator for TSV, generate TSVs, and see how it looks. This should increase iteration speed by like tenfold. And I'm actually pretty happy with the way this is looking. What if we did high walls? Ah, high walls break. That makes sense though, because technically we don't do the second layer. So if we try and spawn walls on top, it doesn't work. Okay. So yeah, there's definitely some logic to be had. To do with depth. But I'm pretty happy with that as a first pass. I think I'm gonna call it here. That's about, we're at like an hour 40. I said this was gonna be another hour and a half, 2 hour stream, so seems good. I'm not sure when you asked that Tempest about offsetting to the wall, but there's no collision yet. That's also the next big step. Part of the reason I'm doing this all as generation rather than the hand painting is not only because I want to be able to swap out pallets and try different things, but we also need to add another tile map under this, which will be a 2D object, another tile map. And that tile map you'll need to add colliders to, and you have to add every single tile where you want collision. And those can be invisible. You don't even have to render it, it doesn't look like. But that's going to be a pain to hand draw in every single tile of collision, unless we can have this thing also generate collision when it generates the base version of the world. So yeah, that's next steps. Collision is the next thing we do, so that we can't just walk into walls. But cool. This has been a fun weekend. Several streams, getting this tile generation stuff and up and running. I'm not sure if I'll stream the next little bit of progress, which will be honestly probably refining a lot of this and getting collision in, but I'll check back in probably next weekend or 2 months from now. We'll see how things go. But yeah, thanks for those of you who hung out. I appreciate the company. And for now, this will be Tolhi signing out. Later, guys.